concept which we are using to design the system. In third unit, in third chapter, third part, it is related to decision tree, one of the algorithm which we use. Okay. So what is decision tree here? So decision tree is nothing but we have to decide something. Okay. So if you take one example, if you go to or now it is lockdown. Okay. Take today's pandemic situation. In these ways, you are not allowed to go out. Okay. So what is happening here? You want to get something or you want to see movie. Okay. So what you will decide? You will decide based upon the situations. Now the situation is very worst, so you will not go to movie. But in the previous days, many of you have enjoyed and many of you have did many things. That is nothing but you went to hotels. Okay, you have seen movies. At that time, the situation was little bit okay. Okay, so what you are doing here is according to the situation you are deciding something, yes or no. Okay, so this is nothing but decision. So here if you take one example, one paragraph is there. X is company, A is the CEO of company. Under this CEO, there are many different departments. And under this departments, there are number of project managers. And under these project managers, many employees are working. Okay. So now this paragraph can be represented as, I'll show you. So paragraph can be presented as CEO. Under this, many department heads are there. Okay, department head 1, 2, likewise. Under this department heads, many project managers are there. Project manager 1, project manager 2. So likewise. Okay. So in the same way, under project managers, there are different types of employees who are working, employee 1, so on to employee N. So I converted my paragraph into tree-like structure, tree-like representation. Okay. So decision tree is used to form tree. It is used to form tree-like structure for the data. That is nothing but, or it is used in the form of hierarchical structure. So what we are doing, we are forming some hierarchy from top to attributes. What are the attributes if you take any data? So whatever the table which I have sent to you, in that you are having 4 attributes. What are those 4 attributes? Some temperature, humidity. Okay, so likewise. So those are nothing but these rounds, these nodes. Okay, so those attributes are represented in the form of nodes. And we will be using directed link. So whatever the line which we are using in between these two nodes, this is called as directed links or edges used to link between the nodes or give some relation between these nodes here. Okay, so we are giving some relation between all the entities or attributes. Okay, so here a hierarchical structure consisting of all the nodes and directed edges, that is called as decision tree. So what we are doing here, we are establishing some relationship between different attributes and different attributes here. So attributes also called as features. Okay. So here you see. So outlook is one attribute, humidity is one attribute, wind is one attribute. So likewise, what we are doing, whatever the data which is there, so that we are converted into a particular tree. So we are representing that particular data set into a tree-like structure. So this is called a decision tree. Okay. So now, if you take, let us consider some data set. If you take whatever the table which I have sent to you, consider that data set. So in that data set, it consists of n number of rows. Okay, how many rows are there in your table? 14 rows. What I have sent to you, the table. Okay, in the data set you are having 14 rows and n number of columns. N number of columns, how many you are having? 4 columns and with one target concept. That is total 5. So 4 attributes and one is called as class label or target concept. The last column is called as target concept. Okay. So in the table, different columns are there and different rows are there. So these are all represented with attributes and this particular column is called as class label or target concept. Now we want to build some decision tree to this particular data set. So it will have one primary node that it is also called as the root node. So whatever the node which is there, that is on the screen you can see that starting node, it is called as root node. Okay, so root node will not have incoming edges, but it has 2 or more outgoing edges. So in between these nodes, what we are doing, we are giving the link and we are forming the tree. So in between these nodes, the between nodes, whatever the nodes which are there, those are called as internal nodes or tree growth. So these are called as internal nodes. Okay. So the nodes which don't have any node, those are called as terminal nodes, and these are called as terminal nodes or leaf nodes. Okay. So there we don't have any growth or the tree branches to that particular node. So those are called as terminal nodes. Okay. Now we will have some conditions. So what are the conditions which we are having? If you see here, sunny, overcast, rain. So for humidity, if it is sunny, if the outlook is sunny and humidity is high, we cannot play tennis. That is no. So this way. So what is happening? So we will be having different types of conditions. Sunny, overcast, rain, or yes, no. So likewise. Okay. So if outlook is sunny and humidity is high, we cannot play tennis. So based upon the condition, we will decide whether to play or not. Okay. So these are all called as test conditions. Okay. And this decision tree in memory is represented in the form of linked list. I think you know what is linked list. So this is the root node. Okay. To this one node is attached. So likewise, whatever the data or whatever the decision tree which is there, that is represented in the form of linked list in memory. And this tree travels from left to right. That is, in decision tree, this is left and this is right. First we will construct on the left side, then we will construct on right side. Okay, so every time decision tree or tree travels from left to right, we construct the tree in top-down approach. And we can also derive some decision rules to this. So whatever the in this example, if you see, there are different types of conditions here. Okay. Even condition, then I'll move on to first slide. So if you see here, if outlook is equal to sunny and humidity is equal to high, then play tennis. Then we won't play. We cannot play tennis. If outlook is equal to sunny and humidity is equal to normal, then we can play tennis. So likewise, what we are doing, we are deriving several decision rules over data and forming a decision tree here. Okay. So decision tree representation, each internal node is an attribute. Each branch corresponds to attribute value. Each node, leaf node assigns a classification. That is classification. Okay. So how would we represent that? So if you are having data set and that target concept is specified with Boolean value, that is yes, no, true or false, positive, negative. So in this way, so target concept అనేది last column ఎట్లా ఇస్తున్నాం మనం yes, no గా positive, negative గా లేకపోతే true, false గా మనం స్పెసిఫై చేస్తున్నాం మన డేటాకి. Okay, so how it can be represented? So that I'll show you after telling. And here each leaf node has assigned some class labels that I have told you. Okay. So here you can see each node is represented with no, yes, so likewise. Okay. So now how can we build decision tree? So this is the main thing. So here, what are the necessary measures in order to construct the decision tree here? So for this, what we need, we require a set of attributes and features. So attributes are nothing but features only. Okay. So from the data set, what we are doing, we have a number of attributes. So we cannot store all the attributes into memory. So what we will do, we consider only most relevant attribute and construct that tree. Example, if you take your details. Okay. So in your details, what you are having, hall ticket number, name. Okay. Next, marks. And in between this, cell number will be there, date of birth will be there, age will be there. So likewise. So what is happening? No need of taking all these things, all the attributes into consideration, all the details into consideration. So these are different attributes which you are having. Okay. For a student data, I am considering these attributes. So with these attributes, if I want to consider construct decision tree. So what I will do? All the attributes is not necessary. So what I'll do, I'll eliminate some. So what the particular attribute I'll eliminate? If you take date of birth and age, so both are not required. You can take any one, either date of birth or age. So likewise, what we are doing, we consider only the relevant attributes and construct the tree. Okay. So that is called as test condition. So based upon the test condition, we will decide which particular attribute to be taken into consideration. So it is also called as attribute tested condition also. So it consists of different Boolean values, that is yes, no, 1, 0, positive, negative. So based upon all these things, we will consider different types of relevant attributes. So first we have to decide the number of features for the decision tree, and then we have to grow the tree with different splits. So first we have to take the root node, then we have to split which particular attribute to the next node. to construct the decision tree. So these are all can be done by using different algorithms. Okay. So here, whatever the splitting which we are doing, this is called as recursive binary splitting. So what we are doing, we are having one node, to that you are having binary value, true or false, yes or no, sunny, windy. So likewise, some two values will be there. With this, we will construct the tree, and that is called as recursive binary splitting. And here, whatever the algorithm which we use, that is recursive partitioning, and it is also called as greedy algorithm. So whatever the recursive algorithm or recursive partitioning which we are using, that is also called as greedy algorithm. So in decision tree, we are using test condition based upon the greedy algorithm with different techniques, and then we will draw the decision tree here. And here splitting is done by two ways. So here splitting is done by two ways. So one is in this way, one node and two outputs. This is called as binary. Okay, and one more type is there, that is multi-way splitting. So three outputs you will get. So whatever the tree which it is there, this is multi-way splitting. We have three outputs, that is sunny, overcast and rain. So here it is multi-way splitting. Okay, and binary splitting, this is nothing but attribute value based upon the split condition. We will split the attributes here, and the two types which we use to split the conditions or to draw the decision tree, those are nothing but one is binary and another one is bushy. Okay, two types of trees which we are using, this and this. One is, for this we are using binary or bushy. So to know about all these things, just I am saying, no need to worry about all these things. Okay. And here, how to choose the splitting condition. So how to choose this splitting condition. So this is based upon various measures. Example ఏంటి అని అంటే, మీరు కాలేజ్కి రావాలి అని అంటే నేను ఏ కండిషన్స్ పెడతాను, మీరు ఎగ్జామ్ రాయాలి అని అంటే నేను ఏం కండిషన్స్ పెడతాను, you have to come to the college regularly and you have to maintain the attendance, 75% attendance, you have to write all the exams, mid exams and everything, and you have to pay the fees. So these are all different measures. Based upon this, I will decide whether I should give the permission to you or not. So you will be using various measures for splitting criteria. Okay, so here you will have one root node. How to get this particular root node and how to split the root node into binary or multi-way. So these are all can be done by using various measures. Those are called as entropy, okay, information gain, Gini index, all these things. But only you are having entropy and information gain. Okay, so what you do here is we calculate the information gain for each and every attribute which is there. Okay, and based upon that only we will decide which particular attribute should be the root node and which particular attribute should be the middle nodes or internal nodes. Okay. And here there should be a stop criteria for decision tree, and there should be some stopping criteria. So when to stop? So based upon the two conditions, we stop the tree. So what are the two conditions here? So here two conditions are, one is minimum number of training instances, minimum number of training instances. Second one is depth. What level to build the tree? What is the longest path between the root node to the leaf node? So these are all can be done by using the information gain and entropy. Okay, entropy and information gain. So these are all will tell you when to stop the tree and how to build the tree and which particular node should be the root node and all these things. Okay. So here there are different types of advantages and disadvantages for decision tree. The advantage of decision tree, the first one is it can be used for classification and regression. That is nothing but take the example. In your class you are having 60 members. What I have to do? I have to classify into two, boys and girls. So how I will classify? Based upon the gender criteria, I will classify the data into two, boys and girls. So at that place we will be using decision tree. Inko example ఏంటి అని అంటే whether the bank people can give loan to the customer or not. So how the bank people will decide? They will decide the customer details. So they will be checking the customer details. How they will check whether the customer is doing job or not, his earning is good or not. So based upon that, to give loan is correct or not. So based upon that, they will decide. Okay. Next is it works well for categorical and numerical data, and it is also called as CART. C-A-R-T. CART is nothing but classification and regression trees. Decision tree is also called as CART, classification and regression tree. Okay, and there is one disadvantage for a decision tree. That is nothing but there is two terms which is associated with decision tree. That is variance. Variance is one. Second one is bias. So what is variance? Variance is nothing but inconsistency. Bias is nothing but inclination. Okay. So inconsistency is nothing but you have some expectation and result is something, some other thing you have got. So that is consistency. So this should not be there. And this is there by using decision tree. Okay. And for this, to overcome this, again we will be using two techniques. For variance, we will be using bagging. Okay. And for bias, we will be using boosting. Okay. So bagging is used to reduce the variance and boosting is used to reduce the bias. Okay. So this is about your decision tree. So now, how to build the decision tree? By using different measures. So what are the different measures? That is gain ratio, information gain, etc. So these two, entropy, gain ratio and information gain is used to build the decision tree. These are different measures which are used to build the decision tree. Based upon this only, we will decide which particular node will be the best node. Here, before going to the example, the basic decision tree learning algorithm is nothing but it takes the basic concept of decision tree and some variations or some different properties which employs the data. Okay, and here in decision tree learning, by using top-down approach and the greedy search, we will draw the tree here, And here for drawing the tree, we are using two different algorithms. So what are the two algorithms which we use? That is ID3 and C4.5. Okay, and ID3 is nothing but it is introduced by rows. I'll show you that. So here it is. So ID3. ID3 is nothing but iterative dichotomizer. Okay, so ID3 is the algorithm which we will be using in decision tree. ID3 algorithm and ID3 technique or C4.5, and these two are developed by Rose Quinlan. ID3 is developed in 1986 and C4.5 is developed in 1993. Okay, and here ID3. So if you take ID3 concept, so which attribute should be tested at root of the tree? So what we are doing here, we are generating the decision tree. So here to generate the decision tree, what is the root node to be taken? Which particular attribute will be taken as the root node here? Please, can you listen to me? Hello? So you have to tell me that screen sharing. Can you see the screen? Till now, I think you have not. It is not visible to you. Yes or no? Yeah. So to build the decision tree, we will be using ID3 technique and C4.5. So ID3 is nothing but it is used to select a particular best attribute to be as a root node. So there we will be using information gain and entropy. So based upon that only we will decide which particular node will be the root node. Okay. So till now I've sent you this table. Okay. So for this data set, I'm using decision tree. To draw the decision tree, I'm using ID3 technique. Okay. ID3 is nothing but in iterative dichotomizer 3. It is developed by Rose. Okay. So now what you have to do here is, in this data set, how many rows you are having? 14 rows. Okay. And 4 attributes. What are the attributes? Outlook, temperature, humidity, wind. And play tennis is called as class label or target concept. Okay. Now, in this 14 attributes, 14 rows or 14 instances or 14 training examples, 9 are positive and 5 are negative. Can you see that? 9 అనేది yes and 9. 5 అనేది no అని ఉన్నాయి. మొత్తం 14 లో 9 plus 5 is nothing but 14. Now what you have to do, you have to calculate the entropy S. Entropy S is nothing but the total entropy for the data set. The total data set ki entropy find cheyali. So why we are using entropy here? Entropy is nothing but entropy is used to characterize the impurity of the arbitrary collection of different examples. So what we are doing, we are eliminating the impurity in the attributes. So to get the information, first we need to know what is the information theory, that is nothing but entropy. And here entropy is used to characterize the impurity of each and every example which is there in the data set. Okay. Now, S is nothing but samples. How many samples are there? 14. In this 14, based upon the last column lo yes and no and yes and 9. That is 9 plus ante positive. How many no are there? 5. Minus ante negative, that is no. Okay. Now calculate the entropy of S for this particular data set. That is equal to the formula for entropy is entropy of S is equal to minus P log 2P minus P of log 2 of P minus of minus P log 2P and minus P of log 2P. So this is your entropy formula. Okay. Now minus P and the positive and negative values. How many positive values are there? 9. Ante 9. So here you can see 9 by 14. So 9 is S value. 14 is nothing but total rows. How many rows you are having? 14. So that by 14. Log 2 of 9 by 14 minus 5 is nothing but no value. How many no are there? 5. So 5 by 14 log 2 of 5 by 14. So that is equal to, you will be getting as 0.94. So please take pen and book and calculate the problem. You will be getting this problem for 10 marks. Okay. So first what you are doing, you are finding the entropy. That is, you are finding the impurity of the data. Impurity of total data set. Okay. So here entropy of S is equal to 0.94. Now what you have to do, you have to find the entropy for each and every attribute. First of all, you will first what you are doing, you are finding the entropy for the total data set. So what is the first attribute you are having? Outlook. Take the second column in your table. Second column ఏంటి? Outlook attribute. Outlook any outputs ఉన్నాయి? Sunny is one output, overcast is one output, rain is one output. Okay. So now if you see here, so if you see here, S of Sunny brackets లో 2 plus comma 3 minus. What is 2 plus and 3 minus? అంటే ఇది ఏంటంటే టోటల్ టేబుల్లో అవుట్లుక్ లో సన్నీ ఉన్నాయి. 1 ఫస్ట్ రో లో సన్నీ ఉంది, సెకండ్ రో లో సన్నీ ఉంది, 8th రో లో సన్నీ ఉంది, 9th రో లో సన్నీ ఉంది, 11th రో లో సన్నీ ఉంది. ఓకే. సో హౌ మెనీ ఆర్ హ్యావింగ్ 5 సన్నీస్. ఆ 5 సన్నీస్ లలో సన్నీకి రిలేటెడ్ గా ప్లే టెన్నిస్ లో ఎస్ ఎన్ ఉన్నాయి, నో ఎన్ ఉన్నాయి. ఫస్ట్ రో లో సన్నీ ఉంది, సన్నీకి నో ఉందా, ఎస్ ఉందా? Guys, I'm asking to you. Table, take the first view, outlook. Outlook lo first output ఏమొస్తుంది sunny అని ఉంది. Take the one output that is sunny. So sunny ki yes no ఎన్ని ఉన్నాయి? Tell me that. How many yes are there? How many no are there? Switch on your mics. Switch on your mics. Anybody. And they tell me in the table for the first attribute you are having 3 outputs or outcomes. For these 3 outcomes, take the first outcome that is sunny. For sunny, based upon the plate in this column, how many yes are there, how many no are there? Tell me. Make it fast. Yes, 2 yes and 3 no. Right. Now, so here 2 plus and 3 minus. Now what you are doing, you are finding the entropy for sunny, individual attribute, first outcome. That is not first, one outcome. One outcome in the sunny. Okay. So here outlook ki any outcomes, 3 outcomes. One is sunny, overcast and rain. Now take the first sunny. Sunny ki 5 total values unnai. Plate tennis lo. Plate tennis lo yes and unnai, 2 unnai. Minus and 3 unnai. So now entropy of S of sunny is equal to, the formula is minus 2 by 5. My 2 is nothing but a positive value, 5 is nothing but total rows of sunny. Any sunnies unnai? 5 sunnies. That by 5, log 2 of 2 by 5 minus 3 is nothing but no. No for sunny. 3 unnai by total n unnai sunny lo 5. So what we are getting the value as 0.97. In the same way, for second outcome, that is overcast. Now tell me how many are there? Overcast in the bottom. How many overcast in the first column you are having? Overcast and a word. Meet below any unai 4. Okay. Now, if you see there, if you see there, 4 plus 0 minus. So now what is happening here is, if you are getting equal rows, equal positive rows unna, equal negative rows unna. Sorry, only positive rows unna, only negative rows unna. Every time the entropy for that particular attribute with that particular outcome always will be 0. So ఇది గుర్తుపెట్టుకోండి. ఆ కాలమ్ లో ఒకవేళ 4 పాజిటివ్ ఉన్నాయి, మీది అన్ని negatives లేనే లేవు. So always the entropy will be 0 here. If you are having 0, 4 negative, then also it will be, the entropy value will be 0 here. Okay, so no need to calculate, you can put 0 for that. That is nothing but for the particular attribute, for that particular outcome, if you are having only positive values, if there are no negative values, the entropy will be 0. Or if you are having only negative value, there is no positive values, then you will put entropy as 0. ఓకే, ఇక్కడ ఓన్లీ మీకు పాజిటివ్ వాల్యూస్ ఉన్నాయి, 4 ప్లస్ ఉంది. సో ఏంటి అని అంటే నెగిటివ్ వాల్యూ లేదు కాబట్టి ఆల్వేస్ ద ఎంట్రోపీ విల్ బి 0. Now in the same way calculate the entropy for rain. In the first column outlook, rain value, rain endunnai 1 2 3 4 5, there are 5 rain. To that particular rain, based upon the platelets, there are 3 positive, and 3 yes unnai, 2 no. Now the entropy for that particular attribute outcome rain, that is equal to 0.97. Put the value in the formula, then you will get 0.971. So in this way you will calculate the individual attributes, individual outcome values, entropy values. Now what you have to do, you have to find the gain value, then only you will get the information gain value. Okay, so here gain value is nothing but yes. Yes is your entropy, comma outlook. Outlook is your attribute, that is equal to entropy of yes. Entropy of yes is nothing but this is the total entropy for the data set, the total data set. This one. Okay, so that is nothing but entropy of yes minus sigma of S of V by S, entropy of SV. So this is the formula which you will be using to calculate the gain value. Now for individual attributes, gain value is entropy of S minus, what is the 5 by 14? 5 by 14 is nothing but the value for Sunny. Sunny total yes no value entundi 5. How many Sunnies are there? 5 Sunnies by total any rows unnai 14. Entropy of S of Sunny minus 4 is nothing, it is the overcast. Any overcast unnai 4 overcast by 14 entropy of S of overcast minus 5 by 14. 5 by 14 is nothing but total rain in unnai 5 unnai, 5 by 14 of entropy of rain. Now that is equal to the entropy S value is 0.94, total data set entropy value is 0.94, that you substitute here, minus 5 by 14 into 0.971 is nothing but it is the entropy of the outcome attribute outcome Sunny value, that is 0.971. Substitute that value here, minus 4 by 14 into 0, that is the second outcome value, minus 5 by 14 into 0.971, that is the third individual attribute, third outcome value, that is 0.97, that is equal to 0.246. So this is only the gain value for the first attribute. Now this is only the gain value for the first attribute. In the same way you have to calculate for all the other attributes, that is for temperature and next humidity and then wind. After calculating all these things, these are the values which you will get, the gain values. Now what you have to do is, after calculating the gain value, now check which attribute has maximum information gain value. Gain is nothing but information gaining. Okay, so information gain for the particular outlook value, outlook attribute value is equal to 0.2464. In the same way, information gain for the attribute temperature is equal to 0.0289. So for humidity 0.15, and for the information gain for the attribute wind is 0.04. Now what you have to do, which attribute has the maximum information gain? From all these things, which is the maximum one? Just pick out, don't message me. Which value is the maximum one? Guys, respond. Which value is having the maximum value in all these four? Guys, tell me which value is having the maximum value here. Can you listen me? My voice is audible to you? So Outlook is having the highest value. So what we are doing, that particular attribute is taken as the row flow. So here you can see. So Outlook is taken as the row flow. So for Outlook, how many outcomes you are having? Sunny, overcast and rain. Okay. So for overcast, only yes value will be there. So what we are doing here, we will stop the middle link. We will stop there. Why? Because only we are getting yes. But in case of sunny and rain, we are not getting any value. Either it is yes or no, we are not getting anything. So what we will do, we will continue that. Okay. So we will continue sunny and rain. So now what we have to do here is, how many sunnies are there? That is, in first row we are having, in second row we are having, in 8th row we are having, in 9th row we are having, in 11th row we are having. So take that rows only, that particular data only. And now repeat this process from the starting. That is, you have to calculate again what is the entropy for the So after calculating that, for this data, I am getting the values, information values in. So we'll stop this here. Okay, 2 minutes. Now again you have to, what you have to do, you have to take rain mode. Okay, on the right hand side, the third outcome. Take that, calculate the entropy value, individual entropy value, individual information gain values. Yes.
I will be required to attend
Yes.
another meeting. We are meeting right now, so I have to leave, ma'am.
2 minutes.
Okay.
Okay, right. So after calculating that, these are the values which we will get from this. The highest value is for wind. What we will do, we will take that particular wind as a node, and with that we will draw the decision tree, and we will get, this is the final decision tree which we will get. So in this way, we will be generating the decision tree by using ID3 technique. So I don't know how many have you understood.
Yes, ma'am.
Okay. So Palidi, you are leaving now?
Yes, ma'am.
Sandeep
Should I
is there?
share a screenshot?
Yes, yes.
Ma'am, I have a screenshot of whoever's joined right now.
Screenshot. Take a screenshot. Don't leave. Guys, once again I am repeating it. You will be getting this problem.